Hi everyone, today we're going to start 2.6, which is proof statements about segments and angles. Today we're going to be working with proofs. What is a proof? A logical argument that shows a statement is true. A two-column proof, a form of a written proof in which the conclusion, your statements, are written in one column and the justification, reasons, beside them in the second column. When you are writing proof, there are four components. The given, that's what they give you. Prove, what you are trying to prove. A drawing, and sometimes that may be left out, so you might have to draw what's going on. And then four, your argument. This diagram is in your book, so I thought it was important to kind of show you. They give you an example of writing a two-column proof. So in the red here, that's your given. That is always the first thing you're going to write. What you're trying to prove is always going to go in the bottom, and then everything in between are going to be things that you know from facts in the class or conclusions that you can make. So those are all your arguments, everything in between what you're given and your proof. Now, before we go into proofs, let's have a quick review over reflexive, symmetric, and transitive. When you're talking about congruent segments, a reflexive property is saying that segment AB is congruent to segment AB, saying it's congruent to itself. Symmetric, if you're saying segment AB is congruent to segment CD, you can flip it. The segment CD is congruent to segment AB. Transitive is very similar to the law of Sill. So if segment AB is congruent to segment CD, then segment CD is congruent to EF. Therefore, we can conclude that segment AB is congruent to segment EF. This is also true for angle measures. So reflexive, angle A is congruent to angle A. Angle A, or symmetric, angle A is congruent to angle B. Then angle B is congruent to angle A. And then our transitive property, if angle A is congruent to angle B and angle B is congruent to angle C, we can then conclude that angle A is congruent to angle C. Please, please, please make sure these are in your notes somewhere. You will want to know what is the reflexive, symmetric, and transitive properties. All right, so here's our first proof. We're given that angle 1 is congruent to angle A, and we want to prove that angle 2 is congruent to angle A. All right, so with our two-column proof, I want to make sure I write statement on this side and reason on the other side. All right, so like I said before, the first thing you write in the proof is what you're given. And in this case, we're given that angle 1 is congruent to angle A. And our reason is just to say it's given. Now I'm going to look at my diagram and I'm going to kind of make markings to say that angle 1 is congruent to angle A. So these markings right here are saying that those angles are congruent. Now what I'm trying to prove is that angle 2 is also congruent to angle A. So I need to prove that this angle here is congruent to angle A. Well, is there a way that I could say that angle 1 is congruent to angle 2? And the answer is yes. Okay, so I can say that these two angles are congruent. Why? Why can I say that angle 1 is congruent to angle 2? What type of angles are they? They're vertical angles. All right, so now I just stated that angle 1 is congruent to angle 2. I'm done with my proof then. So I can now write what's given, that angle 2 is congruent to angle A, and the reason is by using substitution, or you could actually say it's using the transitive property. So substitution, if angle 1 is congruent to angle A, and angle 1 is congruent to angle 2, therefore, angle 2 is also congruent to angle A, and I'm done. Here's our next proof. Segment AB is congruent to segment CD, and B is the midpoint of AC. I want to prove that BC is congruent to segment CD. All right, so I need to write my statements. And my reasons. So AB is congruent to CD. That's the first thing I'm going to write because it's my given. Now I'm going to look at my diagram and I want to make markings for this. So AB is congruent to CD. Remember, those tick marks just mean that they are the same length. I'm also told that B is the midpoint of AC. So that's another given that I need to write down. So B is the midpoint of AC, and that is also a given. So what does that mean? If B is the midpoint of AC, what's the definition of a midpoint? Well, it's the point in the middle. So so what is that going to help me with? So if I look at my diagram, if AB is half of segment AC, that means that AB and BC are going to be congruent. B is in the middle. So I need to write that down. So AB is congruent to segment BC. And why? Well, that's just the definition of a midpoint. So definition of a midpoint. Sorry, I'm abbreviating everything. All right, so looking at my diagram, I now see that BC is congruent to CD with the tick marks, and so I'm done. So now I can state that in my proof at the very end, if I can scroll down. So BC is congruent to CD, and my reason, I could use either substitution or I could use the transitive property here. So I'm just going to use substitution. And I am done. A theorem, a statement that can be proven. Once it's proven, you can use it for other reasons and other proofs. Given DE is equal to EF and EF is equal to DF. We want to prove that segment DF is congruent to segment DE. All right, so our first statement is DE is equal to EF and EF is equal to DF. What is my reason here? Well, that was given to us. So I can fill in given. Now I'm going to mark this on my diagram. DE is equal to EF and EF is equal to DF. So because they're equal, we know they're the same length. All right, so next, I don't know what my statement is, but my reason is the transitive property. We know the transitive property is very similar to the law of Sill. So if I look back at my first statement, DE is equal to EF and EF is equal to DF. Therefore, DE is equal to DF. I want to write that. DE is equal to DF. All right, my next step, I notice I take my second statement here and now I'm flipping it. Instead of DE is equal to DF, I say that DF is equal to DE. What property is that to take our statement and flip it? Well, it's a symmetric property. All right, and finally, if I move this down, I don't know what step 4 is, but I know that's the definition of congruent segments. Well, remember, the last statement is always going to be what we're going to prove. And so DF, segment DF, is congruent to segment DE. And I can state that. I can go from here to here, because if I know that something is the same length, that's where the equal comes in, I then can say, well, if something's equal, that means that they are congruent. Definition of congruent segments. And I am done.